The sea ice area around the North Pole fluctuates between about 5 million square kilometers on September 1st to 13 million square kilometers on March 1st. Assuming a sinusoidal fluctuation, answer the following. A. Write the sinusoidal function modeling the sea ice in terms of x, where x equals 0 represents September 1st, and x is the number of months since September 1st. I've already set up the axes below. The ice fluctuates from 5 million square kilometers to 13 million square kilometers. I've marked off 5 and 13 on the vertical axis. X equals 0 represents September 1st, and therefore 1 year would be 12 months. I marked off from 0 to 12 along the horizontal axis and broke this up into 4 equal subintervals, where x equals 3 is December 1st, x equals 6 is March 1st, x equals 9 is June 1st, and x equals 12 is back to September 1st the following year. We're told on September 1st, the ice level is 5 million square kilometers. This indicates the point 0, 5 is a point on the graph, which is a minimum. And then the ice reaches a maximum of 13 million square kilometers on March 1st, which is when x equals 6. 6, 13 would be another point on the graph. At this point, let's go ahead and sketch the midline by determining the average of 13 and 5. 13 plus 5 is 18. 18 divided by 2 is 9. This indicates y equals 9 is the midline. And we know this because we're told this is a sinusoidal function. And now from here, knowing the min and max values, this should remind us of a cosine function in which we won't have a phase shift or horizontal shift. Recall the graph of the basic cosine function, as we see here, has a pattern of max, midline, min, midline, max, which means in our case, we have a reflection across the midline, and therefore A is going to be negative. But let's go ahead and find some more points on the graph following the basic pattern over the subintervals. Because we're starting at a min, next we'll be at the midline, max, midline, and back to the min. Let's go ahead and sketch the graph over one period. Again, this should remind us of the cosine function. We could use a sine function, but then we'd have a horizontal or phase shift. So we'll go ahead and use the cosine function, and we'll find the equation in the form shown here on the right, where we have y equals a times cosine of the product of b and the quantity x minus c plus d. To begin, notice the amplitude, which is the distance from 9 to 13, is 4. But again, because we have a reflection across the midline, we know a equals negative 4. 2 pi divided by the absolute value of b equals the period. We'll go ahead and use a positive value for b, and therefore we'll set 2 pi divided by b equal to the period, which we can see is 12, and then solve for b. So 2 pi divided by b must equal 12. To solve for b, we'll multiply both sides by b. This gives us 2 pi equals 12b. Next, divide both sides by 12. Simplifying, we have b equals pi divided by 6. Because we are using the cosine function, there is no horizontal or phase shift, and therefore c equals 0. And then finally, because the midline is y equals 9, the graph has been shifted up 9 units, which indicates d equals 9. And now we can go ahead and write the sinusoidal function modeling the sea ice. We have y equals a, which is negative 4, times cosine of, because c equals 0, the input for the cosine function is just bx, which in our case is pi divided by 6 times x, and then plus d, giving us plus 9. B, determine the x values representing where there's exactly 6 million square kilometers of sea ice. Solve by graphing and round your answer to the nearest hundredths place value. I've already set this up in Desmos. I've already entered the cosine function and the graph is on the left. And now we'll graph the horizontal line y equals 6 and determine the points of intersection from x equals 0 to 12. Clicking on the points of intersection, we have approximately 1.38 and approximately 10.62. Notice between these two values, there is more than 6 million square kilometers of ice. So again, for part B, we have x equals 1.38 and x equals 10.62. For part C, during what months of the year are there more than 6 million square kilometers of sea ice? Well, we know x equals 0 is September 1st, which means x equals 1 is October 1st, x equals 2 is November, x equals 1.38 is in October, so we'll say from October to x equals 9 is June 1st, x equals 10 is July 1st, x equals 11 is August 1st, 10.62 is in July, and therefore we'll say from October to July. I hope you found this helpful.